Hey, Algebra 2, this is Mr. Morales, and I'll be discussing the solutions for Test B from the dreaded rational exponents quiz we took back in mid-November. So, first ones, questions 1 and 2. Evaluate each expression given that A is -2, B is 7, C is 4. This is what we call a plug and chug. You substitute in all your values, so 2 times 7 times 4 minus 3 times -2 times 7. Make sure that when you're using the calculator to separate your negative numbers with parentheses. If you plug this all into your calculator, which you should have done, the answer you get is 98. I did not make work required for these two, so you could have just plugged them in and chugged out the answer. For number 2, we have 14 divided by our B value, which is 7, plus our C value, which is 4, minus our A value, which is -2, plus our C value, which is 4. I plug that into my calculator, and I get an answer of 4. So those two were pretty basic. Now, 3 through 6, write each expression in radical form. It says square in your final answers. That means they wanted the final answers boxed in. If some of you asked for clarification, that's all that meant. But this is the important part, radical form. That means everything should have had a radical or square root symbol involved in your final answer, not just a number like some people gave me decimal answers. So 20 to the 1/3, all that means is that we have a base of 20. We have one of them inside the square root radical symbol being taken to a cube root. So if you wanted to put the one, you could have, and that's fine. If you left it off, that's fine too. Number 4, 12 to the 4/5 power. That means we have 12 being taken to the 4th power, and we're taking the 5th root of that. So here's how you rewrite that one, and that's it. You don't have to simplify it any further. For number 5, we have 6x, in parentheses, being taken to the 7th power with a second or square root. If you wrote the 2 or not, that's fine. With square roots or second roots, you're optional to put the 2 there or not. So I take it either way. Next one, we have a negative symbol. That means I'm going to have a fractional answer. I'm going to have a radical symbol. Whatever's in the parentheses is going to be what's in my under my symbol, in parentheses as well. I have 2 of those being taken to the 5th power. So it's just a matter of replacing numbers. The next one, 7, 8, 9, and 10. Here we've got to reverse. All of our solutions should be written with exponential form. That means everything should have exponents to a something power, not just single digits. So 63, there is one 63 inside the radical, and a basic square root symbol means I have a second root. So this would be simplified as writing it as 163 that I have to the square root. Number 8, I have 82 inside the radical symbol being taken to the 5th power and the 4th root. So what I'm going to write that is 82 being taken to the 5th power, 4th root. That's how you write it. Next one, inside my little radical symbol, I have 6x squared y. But there's only one of these in the radical symbol. So this whole thing, there's one of them being taken to the 5th root. And that's it. This next one, I have a fraction. So whatever's in the house, I'll put that right here, it's going to have a negative exponent. I have 5 of them being taken to the square root. Remember, if there's no number for a root, it's automatically a 2. And there's your simplified versions of those 4. Now we're going to use the products or the properties of exponents to simplify some of these expressions. So 27 times y cubed to the 1/3. I'm going to go ahead and split this up as 27 to the 1/3 times y cubed to the 1/3. This means 27 to the cube root, or the cube root of 27. So the cube root of 27 is 3, and you could just plug that into your calculator. Now we have y3 to the 1/3. When you have an exponent inside parentheses and exponents outside, you multiply. 3 times 1/3 is 3/3, or in other words, 1. So I have y to the 1st power. You could have written the 1, or you could have left it off, but that is your final answer. Number 12, I first divide by coefficients. 40 divided by 5 is 8. That's just basic math. When you have the same base and different exponents, have a 3 here and an invisible 1 there, you take your exponents and subtract the top exponent minus the bottom exponent. So I would have y to the 2nd power. So 8y squared is your final answer there. For 13, I have three terms, each with a coefficient, so I'll multiply those first. 3 times 5 is 15, times 2 is 30. So there's my numerical part of my answer. I have x to the first power times x to the second times x to the fourth. When you have multiple exponents being multiplied together like that without parentheses, all you do is add each exponent. 1 plus 2 plus 4 gives me x to the 7th. And then my next one behaves the same way. 3 times 5 is 15. I'm going to have to add 1/3 plus 1/5. But those fractions have different denominators, so they need a common denominator. Common to 3 and 5 is 15. So 1/3, turn a 3 into a 15, I have to multiply it times 5. So multiply the top times 5, that gives me 5. For the 1/5, to turn that into a 15, I have to multiply the bottom times 3 and the top times 3. So now I can finally add these. 5 fifteenths plus 3 fifteenths is 8 fifteenths. Of course, your calculator would have done that for you if you just typed it in. It would have done it for you and simplified it, because it does basic calculations like that. Hence the term calculator. Moving on, number 15. These ones gave some trouble. There's really only one step you have to do. When you have a rational exponent equation that you're solving for, you raise everything on both sides to the reciprocal, or the flipped version of your exponent. This will cancel out the exponents on the left side. And here's what I have now. I have 25 to the third power, or in other words, 25 times 25 times 25, taken to the square root. Square root, square root, square root. The square root of 25 is 5. So 5 times 5 is 25, times 5 more is 125. And there's my answer. Moving on to number 16. I have on the left side n plus 9 to the 3 halves, which I'll raise to the reciprocal right now while I'm still writing it. And I'll do the same thing to the right hand side. I'll take 27 and raise that to the 2/3. I think I said 3 halves earlier. These cancel out. I have n plus 9 equals 27 squared. So I have 27 times 27 taken to the third root. Third root, third root. N plus 9 comes down. The cube root of 27, one number times itself the third time will give you 27. That number is 3. 3 times 3 is 9, so I have n plus 9 equals 9. Subtract 9 from both sides, and I get nothing left over, so n equals 0. For the next two, for number 17, I have x raised to the negative 3 halves. I'll go ahead and raise it to the reciprocal, which would be to the negative 2/3. And I'll do the same thing to the fraction I have on the other side, and raise that to the negative 2/3. These cancel out, which is what I want. On the right side, a negative means flip your number in parentheses upside down, take the reciprocal. So 1 over 27 just becomes 27. I use the negative sign now, and I just have 2/3. That means x equals 27 squared, or 27 times itself, 2 of them, both taken to the third root. That's where that 3 comes from. Then I have x equals, the cube root of 27 is going to be 3 times 3 again. So I have an answer of x equals 9. And for number 18, I have x plus 5 raised to the 2/3 plus 10 equals 35. I have this plus 10 that's not being affected by my exponent. So I must remove it till I only have the exponent stuff by itself. So I'll first subtract 10 from both sides. When I do that, I have x plus 15 to the 2/3. That cancels out. 35 minus 10 is 25. Now I'll raise the left and right side to the reciprocal to the 3 halves. These cancel out. I have x plus 15 on the left side. 25 to the 3 halves means I have 25 times itself 3 times. 25 times 25 is 25. Taken to the second, or square root. The square root of 25 is 5. So what I end up with is x plus 15 on the left. Square root of 25 is 5 times 5 times 5. So I get x plus 15 equals 125. Subtract the 15 to get x by itself on both sides. I get x equals 110. There it is right there. All right. And then finally, our last two on factoring. Here we look for our greatest common factor in our coefficients. For 12 and 4, the biggest number is 4. So to get 12, I do 4 times 3 times that single x times that single y minus 4 times 1 times 2 x's, because it's x squared, times y, because it's y squared. What's common to both terms? On the left side, I have a 4. On the right side, I have a 4, so I'm going to take them out. I'm going to scratch them out. And then I also have a single x here, a single x here. I take out one x from both sides, a pair of x's. And then I have a y here and another y here to take out, so a pair of y's. The remainder is this positive 3 minus 1 times x times y. 1xy, you could just say xy also, that's fine. So here's our first solution. Our second one, we have coefficients of 4, 6, and 4. The biggest number that goes into all of those is a 2. And remember, there's 3 terms here. So that's going to make a difference in what I can pull out. So let's rewrite everything first. 4 is 2 times 2 with y squared attached. 6 is basically a plus 6, which is 2 times 3. And 3y's being multiplied in succession. Plus, to get a 4, that's going to be 2 times 2 with 4y's attached in succession at the very end because it's y to the 4th power. Now, since I have 3 terms, 1, 2, 3, I got to pull out trios, not pairs anymore, but pairs are groups of 3. So what do I have 3 of? As far as numbers go, I have a 2, a 2, and a 2. That's common to all 3 pieces. So I took out a 2 from all 3 pieces. What else can I take out from all 3 pieces? I can take out 2y's, 2y's, and 2y's at the most. So 2y's, or y times y, is a y squared. I can't take anything else out because there's no more y's in the first term over here. And there's only 1 y here and 2 here, so there's not enough to go around. So that's all I can take out. I have 2 in the front, still remaining right here. Plus sign comes down. I have a 3 and a y, still remaining in the middle piece. Plus sign comes down. I have a 2 and 2 y's, which is y squared. That'll also come down. So there's your final answer there. I hope this helped clarify maybe some of your misunderstandings. And best of luck to you in the future tests.